My name is Viola. I'm a senior software engineer. I've been doing this for more than 8 years now, and a login is one of the painful things that you keep stumbling on, and you can still figure out new ways of fixing things in production. I am a developer, and I do that in my spare time as well. So I have my 5-a-day application, which I'm working on currently. I have my GitHub repo, which I maintain and have contributors, which is great. It's called SnappyCart. It's a card that you can integrate into your e-commerce solutions. I also have a few social media channels where you can follow me and look at my videos, and I talk sometimes about different interesting things. I post my talks there, so if you want to rewatch it, you're welcome to do so. My LinkedIn, my YouTube, welcome to scan and follow. I'd also appreciate a fork on my repo and a star as well, so that you can watch the updates. 5-a-day, if you're interested, 5-a-day is an app that is tracking your 5-a-day intake as per NHS guidelines, so it's a government type application. It's been actually recognized by Tesco, and I've had a meeting with them about potential acquiring of It failed nevertheless. I feel like sharing about that, and they still adopted some of the styles of this app. So, without further ado, sorry?
SnappyCart.
Not SnappyCart, the 5-a-day app.
No, but I found the code. It says SnappyCart.
Yes, this is SnappyCart on GitHub. Yeah.
Is that the same as 5-Day Club?
Sorry?
It's the same as 5-Day Club.
No, it's the two different applications. 5-a-day club here.
Yeah.
You can just type it in. This is GitHub repo. The link is too large to type in, so instead of feeding you with the tiny URLs, just the QR code. Technology. So, yes, authentication. I'm wondering if the mic is working perfectly. Yeah? Okay, so yes, what is keeping your login from actually letting your users get into your application safely without having to do the trials and errors with your login screen? For me, as a person who is focused on SRE approach for site reliability reasons, I like to always test the application with the QA team as well as myself to make sure that we do have a great path where we can restore access quite easily after something fails. And that's why I mentioned here the 3 a.m. runbook, which I'm going to share with you, and I actually have an endpoint where you can download that on my website. So what is an SRE approach to authentication? I mean, it generally applies to anything that you can develop. So an SRE approach is where you automate things, where you manage things by creating something as a developer that would automate a manual, mundane task that is otherwise, quite, you're wasting your resources, the ops team resources, the DevOps team resources on solving something that can be automated. So how can we keep the login from taking down your product? There is a couple of ways you can do that, and I'm going to talk about the authentication in a sense of as a dependency that you can solve in an SRE sense. So authentication is not just a button, and it says here, it's not a button, it's not a screen where you just click login. It's a couple of things that happen in between, so it's a chain of reaction like that you can power with your click. So you click login, what happens then? There is a chain reaction, like, for example, we send a request to our server, then an IDP, identity provider, sends something back, then it validates, then it goes to OK status, and it basically validates you. But it's not that simple because you have things like load balancers, like errors in between that can happen. And if that happens, then what we'll need is resources from the ops team, and the user will be unhappy as well. So the users see it from the way I can't log in, something is going on, and from user standpoint it's just one error. Something just doesn't work, and they feel like, okay, that screen is broken or something. From the ops experiences, it's going to be just like, they're going to see a chart and be like, oh, this is a 401 spike, so 403 spikes that we're seeing. It's not nothing, but it's just like one thing that we're seeing. And that is where everyone trips, because you can't say that because this is a 401, it's just one thing that's broken. It's probably a chain reaction of things in between that you can't see unless you have a framework in place to kind of explore this. And you won't have that unless you map your system and you know what your system is about. Where you have a diagram with different services interconnected, and you have it in front of you when it fails. So that's how we can avoid ops experience, seeing the redirect loops, the token refresh storms, the identity providers throttling, and the page noise, and where the users are like, no, I'm just going to go and use the competitor's website because it's just more stable. But yeah, we need to tackle those issues that users can face potentially with our application, and that's where we need to follow a framework. So when I said we need to see our authentication as a dependency of an SRE system, I actually mean it as that. You need to map your application so that we know, so the blue and the golden kind of screens, they mean that these are the most important dependencies. So this is our main graph of dependency, the first four squares. This is basically our app, right? So this is like where we come into the app. This is our like distribution network. This is the WAF. This is the layer where we do the load balancers and everything. But this is our API. This is like the backend. But this is our one of the services, which is called authentication, where we have the session and the token. Then we go to the golden boxes where we have our identity provider. For example, I use Cognito all the time. Someone could use Keycloak or something else, Okta. It doesn't really matter because, yes, although different identity providers, different rules, but you still have the auth concept on like underneath all of them. If you go to any provider, you'll see pretty much the same boxes about the implicit flows, about things that are, you know, the same as an RFC standard. So yes, this is our OIDC auth. This is our server for IDP provider, for identity provider to store our JWKS. So this is like the key storage, and then the session storage as well. We could use Redis. This is great for cache. I mean, why not? You could use anything, memcached, whatever you can think of. So, and then there's like the red boxes, which are the things that are overlooked by the teams. So, for example, the time sync. When we have some mismatch with the time, our keys will not work, especially if like the identity, someone logs in, the identity provider issues a key, it gets stored, but then when it tries to match, it's not going to be matched with the session, with the person. So it means that valid users become invalid users, and they'll have the issue with your system. The deploys, again, like rollouts, when you're doing a blue-green deployments, when you're doing the gradual rollouts, or just like push to the production, and you need like, I know many people say that rolling out something that you just pushed could help, but when you're trying to guess what you've done to the system, and so it happens that the last thing that you've done was the push to the system, that was, it's just a guessing game, and you probably would be wasting your time if you just roll out the last thing that you've done, because you probably won't be fixing the production. You're just probably going to waste the time. And then, yes, there's rate limits that are overlooked as well. So you gotta think about those when you authenticate people, because so many people like to just click, and then the system breaks because you don't handle it well. And obviously, retries and caches need to be validated in order for them to be like up to date. So yes, there's a lot to unpack in that system, but you have to have that map in your organization, which will map like your authentication servers. So that you, at 3 a.m., you don't run and think about, oh, let's watch a YouTube video to remember what our authentication path is when we set it up like 5 years ago. Oh, the guy is actually not working here anymore, so yeah, we'll call him. So yeah, there's 5 things that I like to actually highlight in the systems that are important to understand, so that you kind of cover the half of the system that can fail, and whatever can work, whatever can fail. Sorry, I'm losing the time. So yeah, the JWKS patch rotation. Yes, I'm gonna go through each of them. There's 5 of them altogether, and we'll just talk about every single one of them. So bear with me. Okay, so the first one is our JWKS fetch rotation. So the symptoms that can be seen in the system when something is wrong with the JWKS, and I'm talking from the perspective of when I'm not trying to guess, oh, maybe it's a front end, maybe it's a cache issue, maybe it's something that broke and I don't really know what, maybe it's a course, maybe something else, and teams waste hours, and I've seen that happening. Teams waste hours on exploring what the issue could be before they can identify what it is. So the symptoms for this, yeah, obviously we can see spike of 401s. If I can see my chart, like in the Datadog or whatever you use, and I see a chart where it says, oh, 15,000 users are currently getting the 401 when they're trying to log into their accounts, and they're not even hitting the rate limiting limits, and they're still getting it. So what could be the issue? But then there has been a key rotation, and now you know, oh, maybe that is something wrong with our provider's JWKS. Some regions can fail. That's again a really nice story about, like, I use AWS. Many people do, and the thing is, we use cloud providers with different service in different countries, so we want them to be all available at all times. And if something fails in India and nothing fails in the UK, how do we know what is going on there? It's not about going and checking their service, they're configured exactly the same. But it's, you know, as a popular meme was saying, is basically, what are you going to do if a system fails in Australia, but it works in Austria? We'll send people to Austria, you know, but we're not going to send people to Austria because they can't access our website. So yeah, that is the kind of stuff I'm thinking about. So yeah, what kind of guardrails can we implement to actually like help save our system? We could cache our thing, like we could cache our tokens. So the thing is, when someone authenticates with our like identity provider, for example, Cognito, they issue a specific key that can be matched then with your original request. So when those keys match, you can actually, like you need them to be confirmed, and you have the same timestamps, you have the same footprint, and if they don't match, then it's failed. So what we need to do is to cache those things, because if we cache our token that was issued by the IDP, then we're sure that if something happens to the network, if there's latency, if there's like a failure in connection, then we still cache it and it's still there, so we won't have to refresh, we won't have to make the user wait, we can return something for them to feed on. And you know, we can always refresh the background, see if they've already made another request, maybe they've actually, you know, they're impatient, and we need to keep the last known keys. So another one is very important is actually we need to have the circuit breaker. Circuit breaker on the JWKS endpoint, I think that's actually one of the most interesting ones because when something breaks in the chain, we typically tend to go and look in the in the identity provider itself. So I go to Cognito and see, like, inspect the logs, what has happened. But I'm not actually thinking about the the chain reaction. So that's where my kind of mapping coming from. So yes, the next one is close queue. I've already mentioned some of this, but yes, typically we want the timestamps to match. We want also to our distributed systems to actually talk perfectly in sync, because if our services are not talking on, let's say, kind of, so they're not aligned with the tokens, so we're using different tokens from different systems. There's so many users, we're handling like millions of registrations, and the thing is, we're using the same IDP with the same user pool, for example, for registering, for updating, for deleting, you know, things like that. And that needs to be handling those requests. And the thing is, you know, if we expire our tokens beforehand, or the tokens get mixed up, because that happens as well, we can mix up the tokens and we can return the wrong token for the wrong user, and that will be bad. So yes, I would log everything that you can on the clock queue, because otherwise we're going to be spending hours and hours in distributed systems to find the core issue for this. Refresh token storms. That is actually a good approach, was outlined in AWS article I've had a look at. So the jitter that is actually combined with a backoff is actually really helpful for refreshing your cache, because you can then do the less operations in a less amount of time, and that would grow, instead of growing like exponentially, it would grow like slightly less exponential. It's not like actual the term, but I can't remember the word, but it would be like this would be the exponential growth, and that would be the backoff plus jitter. So jitter helps to distribute the time, and if you can see the graphs, I'll share the resources afterwards, but the graphs are literally showing the big difference when we have the jitter plus the backoff. So the token storms are real, and we want them to be rate limited as well, and that is when we are deploying something that is really new, when we have like really bad versioning as well for the tokens. That is very helpful. IDB throttling, yes. So this is where many people are actually losing a lot of money. In AWS, for example, that is basically where we have a successful everything going from the login page up until like authorization. We start using the application, and it's timeouts are happening, and we are getting logged off from our application. So we're trying to like refresh. So what we can do is to actually queue the requests that people are making from that system. We could cache what they've already done, and we could cache those JWKS so that we don't keep requesting from the IDP those things. And also we could put some budgeting in place in AWS so that we are not wasting money on this. And the final one is the session store outages. Yes, so this is where we are successfully logged in. We got the message that yes, it's 200 okay. I really like this 200 okay, because people tend to think that this is great, but it's not that great, because when you get a 200 and it goes back to your login screen, it's not 200. Yeah, and that is where we start seeing those logouts after a cache restart. We're seeing like big charts where basically we see people getting logged in, then logged out, and that just looks like this, like spiky charts. So what we can do is make sessions survivable, so we can like actually implement those TTLs, the time to live tokens that would sit in their cookie storage, and help them validate their sessions instead of like going back and forth with redirections and validations and like relogins, relogouts. So yes, Redis is actually a good layer for this one as well, because this helps us cache the JWKS. And then also, I need to mention the SLIs and SLOs. So SLIs is what we actually want our user to, so SLIs are not so much the business decisions based on what the business wants, as it is the customers, what the failure for a customer looks like. So people who would be using your application are going to be your SLIs essentially. And what does it look for them like to have a successful login? We don't really care about the rule of the nines when a user can't log in, even if our production shows that the CPU is great and it's green, and also when we have like a perfect kind of rate of logins and logouts. We want to think about what the user will feel when, with our 3 nines, we still have the issue of user can't log in. So yes, there is some of the measurements I've added here. It's super boring to talk about, but they do help measuring production, what you can do. So the P95, for example, very helpful to see how much the page loads, and then the success rates of the 3 nines. 3 nines are really important, but as well, it doesn't really matter when it fails, it fails. So yes, and the that is one of the things I've actually talked about. So imagine you have the login success, like that, and then you still have a refresh success like that. So this is not actually good. If we zoom in, because there is more refreshes, and they're growing exponentially there, the refresh success, we don't want those refreshes. We want to just have the login successfulness into. So this is literally it's eating our budget, and it's making our life harder as an SRE, because this will be a really the path towards the incident and spending more money. So yeah, the guardrails. I do have some guardrails to stabilize your production. First of all, obviously we want to implement the time to live states. In our cookie session storage, we want to revalidate, we want to do the single flight and the pre-flight as well with course. We want to remove as much as we can the retries. Our retries, they will happen still, but we still need to try and use the backoff plus jitter approach from AWS, and they've been using it since 2008, I think, and that is the only thing that they've actually seen to be working in production in large environments. The reason I'm citing AWS is because they have a user base of thousands and millions of users in different locations across the world. So this is a really good source to take this from. And obviously the feature flags, I would do feature flags. So easy to come back and see what degraded and how we can restore it. So yes, these are some patterns we can apply, and obviously here we have the most that you can actually go through it yourself. I mean, these are literally the where you can apply the patterns that we've talked about, for the previous slides as well. So yeah, this is how your 3 incident runbook would look like. So we would first confirm the user pain. As I've mentioned, the SLIs are supposed to be the user's pain points. It's not so much your business decisions. It's more about the actual pain points that the users are experiencing in lifetime. I cannot register. I cannot log in. I cannot delete my account. I cannot do anything with my authentication. This is bad. So we would actually go by the SLIs here. Is identity provider healthy? We want to make sure that our identity provider, and these are, by the way, the steps that we want to have in a real production environment. So we need the actual step map, instead of going, oh, is it a front end, is it a back end? Oh, we are seeing the 401s. Maybe we should check the server. No, it's not the server, it's your process. You need to check your process before you go to production. And that is one of the things that you need to think about when you are rolling your application out in production. So yes, is identity provider healthy? Do we see anything bad about memory? Maybe, because memory is one of the things that actually fails your production so many times. So need to make sure that it's not so much latency, so that we are not. So that we are not seeing so much latency as we would, otherwise, when the connection is not stable, when the identity provider is overloaded and slowing down because we have our guardrails in place. So is our auth path healthy? Actually, the CPU, those things only matter after we've checked the first things, because if the SLI is not in place and we're not seeing that the user, this is where we actually asking our questions in production. So once we know what the problem is, I can't log in. Now we check the identity provider, only then we go to check the CPU, because so many people tend to rush into the server's checks before we even know what the issue is. Seeing the error from and getting the message from the ops teams doesn't really mean that we know what the problem issue is, and that's why I started my talk with the thing that you have a chain thing in between, you have separate processes that you need to check before you actually know the issue, because those things, they don't just fail because they fail, especially in distributed systems. You have separate services that are responsible for the authentication, for different backend operations that you would have. Monoliths are also failing really well. But this is when it comes to the CPU, only after you know and confirm what the issue might be, you go check the CPU, if the database is running, if it's reading and writing as supposed to, if there's caching in place, if it's still working, if it's an operational layer, or if it's degraded. The queues, are they still queuing? And then we're actually asking ourselves, are we stampeding? Our JWKS, are they actually working? Do we have it up and running? Is identity provider, I know it's taking care of many things, identity provider, but so many systems are literally bespoke systems, and you need to ask yourself, do you really want to manage that? Or if it fails, who's going to be responsible for this failure here? Because we need to get our production back on track at this point. So the guardrails that I've talked about before that, and I've showed you the some of the guardrails that we could implement here. Backoff and jitter, one of the things that I would absolutely go for, because it reduces the actual time that you would it would reduce the error rate, and it would reduce the failure modes, and it would actually show you the gradual the gradual graph where you have less, let's say you are spending less money essentially. That's my idea. That was my idea was. So okay. So yes, degrading safely, that is actually a very important issue because we have existing sessions in place. So if we shut down the whole system, would those sessions still be alive? That is a really good question to ask because we don't want to shut down the entire server. That's why we have to have a strategy where we have a separate server where we will back stuff up, where we will let people continue getting off with their business as they wanted to, instead of literally getting locked out from everywhere. So yes, and obviously mitigation, we need to mitigate by reducing the load on the system, maybe sign off stuff that is not active or present, maybe allow more provision, allow for more space and provision more space and allow more memory, maybe more RAM, maybe more CPU power. That depends on the system solely. I'm talking from what I remember from the last time I've set up. And obviously we need to have the recovery states for our system. If we don't know how to recover our system from the failure, we will definitely drown in those requests, and the ops team will drown, and the DevOps will be shut down, and everything is going to be really, really bad. So we need to have the habit of actually the recovery states, and obviously the postmortems. Postmortems are what rolls the production, and I think if I didn't write postmortems for every single incident I had, I'd probably be somewhere I don't know. It would actually be very difficult to come back to the things that I've already gone through. And I know for so many times that my team has actually read my postmortems and they actually understood the issue clearer and faster. So this is the resources page on my website. You can scan that QR code, and that is the one that you want. I haven't published though the runbook there, but the slides are there already. I will publish my runbook as soon as this session ends, and you will have your access to the runbook that I have here. It's a special PDF that will help your team to kind of set the guardrails in place. So these are some takeaways for you to screenshot. I think any questions are welcome.
Excellent talk. Thank you so much. Does anybody have a quick question for Viola? Well, there's a few. I'm going to go to you, sir, because you've got a nice smile.
Thank you for the presentation. So, going back to your first diagram, it looks like you have a front-end application which is trying to access backend. And it seems like you're using backend for front-end pattern. Have you considered looking into alternative patterns, because you have session management, topper management, or the top of jitter and all these mismatches, all the issues you mentioned. Have you considered looking into a debug which or demonstrating proof of possession or things like that have to be considered, or why you decide to go with the BFF pattern?
Yep, nice question. Thank you very much. Yes, this is actually a good notion. This particular one was an XJS application with the actions, with server actions that were running through AWS, and it's a good pattern for applications that are not scaled so much, that are used by thousands of users, not by millions of users, but you can still scale. So one of the things that I've tried before is Keycloak. That is a bespoke system where you have different services on the backend, and you are authenticating from the backend, and you have some front-end code running on your somewhere on the server where you're distributing it through the CDN. The thing is, with backend for front-end pattern, I found that it was useful because it allows you to start up the application faster rather than creating the whole service for the application. You're not wasting so much money on hosting. You're keeping everything so secure because you're distributing it across different providers. Yes, it's not an in-house approach. You can absolutely have your Kafka servers in place, like spinning out your Docker containers and your application with your backends, serving somewhere across the network. But I think for the BFF approach, it's actually interesting because you're interacting with different providers and you're spreading out the costs and you're spreading out the responsibility for each service. At the same time, you need an SRE engineer for such a system that is going to be looking out on those platforms for the issues that might arise, and you still need to log a lot. There is so many more attacks that you can do on the front end that you can do to the back end because it's not as secure as the back end. So that makes it so much interesting to me because you can work with the SSRF tokens and you can work with different kind of SQL injection attacks if you have a database that happens to run SQL. But you can also use DynamoDB, which is a dictionary, which is fine to use, on some small system or the system that needs a fast lookup. So I think that I've tried different patterns, but I pretty much stuck with this BFF approach for the past 2 years, I think, and that sort of thing worked for me before. So yeah.
Wonderful, excellent, comprehensive answer. I think we've just got one more.
Yes. Okay.
Yes, go on, one more. Anybody else want a question? All round the back. Okay, hang on.
Whoever have a question and will not have some time today, sorry, you can always text me on LinkedIn. I'll respond.
Thank you, Viola, for the talk. I have one question, or maybe two together. One question. Cool. So, when authentication breaks in prod, what's the first signal you look for or look at? And if you do have guardrails in place, what's the best one that you choose for containing the blast radius?
Thank you very much. That's a great question. The first thing I'm looking at is what has actually happened. So I'm not taking it from the ops team as granted. If I don't care about what error, I need to see what actually happened in production. For this, I use replays. I need to see what happened on the heat map. I need to know the details of the user's actions and reproduce the issue. So once I can reproduce the issue and see exactly what they had, like the network, the latency, the kind of connection that they were using, and the kind of browser they were using, so then I will be able to confirm the issue once I know what the user actually experienced. So once I know what the user experienced, I will then go and explore what my system has to offer. I'll go through the logs, I'll go through the chain of different scenarios of what might have happened. So I spend some time planning rather than going deep diving into resolving, because I know that will take me hours to resolve if I just go one by one in a linear approach. But instead I'll just look at what the issue might be, particularly as I mentioned the markers. The markers are actually what happens to help me in production so much, where you can look and pinpoint a particular issue from the start. You can go wrong. Yes, obviously, you can obviously go wrong with what you think might be the issue, because the markers can be, there could be two things that are failing and you're looking at just one. So, and by two things, I mean there could be two chains of things and reactions that you can, your user might have started when they try to log in. So once they click that login button, what happens in your system is up to the flows that you've defined. Depending on the network's availability, depending on the CDNs, how you distribute things as well across the network, and how they will receive the keys in the browser. that will, depend on how they will experience, what they will experience in production. So that's how I would go about exploring and actually like finding out what's broken in the system. But yeah, I hope that sort of answers.
Wonderful, excellent. Thank you very much.